Hello everyone and welcome. If you ever try to simulate ceramic materials in Abaqus, you already know that they are among the most difficult engineering materials to model accurately. Unlike metals, ceramic exhibit brittle fracture, pressure-dependent strain rate, sensitivity, and complex damage evolution under high-speed loading conditions. Capturing this behavior requires advanced material models, careful numerical techniques, and a solid understanding of the explicit dynamic analysis. To help engineer, researcher, and graduate student master these challenges, I'm excited to introduce the ultimate Abaqus ceramic and silicon carbide analysis package, a comprehensive training program consisting of 24 real engineering workshops. This package has been developed for anyone who wants to perform professional ceramic simulation using Abaqus. Whether you're working defense engineering, aerospace engineering, material science, biomechanical engineering, or advanced manufacturing. One of the biggest strengths of this package is that it focuses on the real engineering problem, not simplified classroom example. Every workshop is based on the practical application that engineers and researchers encounter in industry and academia. Throughout the course, you learn how to simulate uh, high velocity impacts on ceramic armor system, investigate ballistic impact, penetration analysis, blast resistance, composite structure, model advanced sandwich panels, simulate cold spray deposition, perform ceramic machining simulation, study biomechanical ceramic applications, and evaluate the structural behavior of composite panel under bending loads. A major highlight of this package is the implementation of advanced ceramic constitutive model, including the Johnson-Holmquist or JH2 and Johnson-Holmquist Beissel or JHP material model. We can also mix the ductile damage with Drager-Parker model to make ceramic like the GAHB or JH2 model. These models are widely used for predicting the behavior of brittle materials subject to extreme pressure, high strain rate, ballistic impact, and explosive loading. Understanding how to use this model correctly is essential for producing realistic and reliable simulation results. The package includes or contains 24 workshops, each designed to teach a different aspect of ceramic analysis. You learn how ceramic UHMWP armor system resists projectile penetration, how ceramic plates protect concrete structure using the SPH method, and how multi-layer composite uh, armor reduce behind the armor blunt trauma, as you can see it here. Several workshops focus on hybrid armor system combining ceramics with aluminum foam, titanium, CFRP, AFRP, epoxy, and other advanced composite material to improve energy absorption and impact resistance. You'll also study oblique projectile impact, multi-layer steel ceramic structure, penetration depth prediction, and the behavior of the boron carbide and silicon carbide under severe loading conditions. Blast engineering is another major topic covered in this package. Multiple workshops demonstrate how to simulate air blast explosion acting on ceramic composite structure, lightweight sandwich panels, lattice core designs, and the sequential blast loading. The example help you to understand how protective structures respond to explosive event and how different material contribute to blast mitigation. Beyond impact uh, and blast simulations, you'll explore advanced manufacturing and biomechanical applications. You'll learn how to simulate the cold spread process on a steel and titanium substrate, investigate the machining of silicon carbide using rigid tool, uh, analyzes the pull-out behavior of the ceramic orthopedic nail here, you can see that, and perform three-point bending simulation of hybrid composite panel as you can see it here. But this package offers much more than the video lesson. When you purchase the course, you'll receive the complete CAE file ready to run, INP file, detailed step-by-step video tutorials, reference research paper whenever they are available, and implementation file for JH2 and JHP material model, the codes. These resources allow you to reproduce every simulation, understand each modeling decision, and customize the example for your own research or engineering project. Whether you're preparing a journal publication, working on graduate thesis, developing new protective material, or simply expanding your Abaqus skills, these resources can save you significant time and help you build confidence in advanced explicit dynamic simulation. This package is suitable for mechanical engineer, aerospace engineer, material engineer, biomechanical engineer, finite element analyst, researcher, graduate student, and anyone interested in advanced ceramic material models. If your goal is to move beyond the basic Abaqus tutorial and learn practical techniques used in the real engineering application, this package is an excellent uh, resource. At the end here, we have the payment method and the price. The price for this package is 147 euros. We accept PayPal, Visa, MasterCard, and cryptocurrencies. And after payment, you'll receive the download links from Google Drive for all the files. Before that, contact us through this email to tell you more about the purchasing process, the content of the package, or anything that you need to know. For now, thank you for your attention.